Let's take a problem on latches. Here you are given another latch and it contains an OR gate, an AND gate, and an inverter. So in this latch, what should be the restriction on R and H such that Q and P are always complementary? So this is basically an XY latch where X is R and Y is H. So for this latch, what should be the restrictions on R and H so that Q and P are complementary? Remember in the SR latch, if S is 1 and R is 1, your circuit is going to be unstable. So in the SR latch, S equals to 1 and R equals to 1 is the restriction, and it's not allowed to be your inputs. So in this case, what are the values of R and H which are not allowed as inputs to the circuit? So let's work this out. Whenever you're given a problem like this, take the truth table, the two inputs R and H, and the present value Q. So you have 8 different combinations, and we are going to check Q plus and P plus for each of these combinations. We are going to flag those combinations where Q and P are not complementary. Let me take an example and show you how this works. Initially, R and H are 0 and Q is 0. So R is 0, H is 0, and Q is 0. Let's see what happens. The 0 goes all the way down here. So 0 and 0 is 0. 0 flip is 1. This 0 goes all the way up here. And Q remains at 0 because 0 or 0 is a 0. So this circuit is stable where Q plus is 0 and P plus is 1. So Q plus is 0 and P plus is 1. Let's take the next combination where R is 0, H is 0, and Q is 1. In this case, the 1 comes down here. 1 and 0 is a 0. 0 flip is 1. 0 goes up here, and 1 is removed because 0 or 0 is 0. This 0 goes down here. 0 and 0 is 0. 0 goes up, and then the circuit stabilizes. Therefore, Q plus equals to 0 and P plus equals to 1. In both these cases, the condition satisfies because Q and P are complementary. So these inputs are okay. So this circuit can have R equals to 0 and H equals to 0. In fact, if you look at this more closely, this corresponds to the reset state because your Q plus is 0 no matter what Q was in the previous state, if R and H were 0 and 0. Let's take the next combination where R is 0, H is 1, R is 0, H is 1, and Q is 0. Let's see what happens. 0 goes down here. 1 and 0 is 0, flip. 0 goes up, remains at 0, and the circuit stabilizes. Therefore, when R equals to 0, H equals to 1, and Q equals to 0, your output is a 0. That is Q plus equals to a 0 and P plus equals to a 1. Q plus is 0, P plus is 1. Let's take the next combination. R is 0, H is 1, and Q is 1. So when Q is 1, 1 goes down here. 1 and 1 is 1. 1 flip is 0. This one goes up. 1 or 0 is 1, and the circuit stabilizes. Therefore, when R equals to 0, H equals to 1, and Q equals to 1, your Q plus is going to remain at 1. This will be 1, and this will be 0. And if you look at this, this corresponds to the hold state. In both these cases, P and Q are complementary. So these inputs are okay as well. Take the next combination where R is 1, H is 0, and Q is 0. 1, H is 0, Q is 0. Let's see what happens. So 0 goes down here. 0 and 0 is 0. This goes to 1. This 0 goes on top. 1 or 0 is a 1. This 1 goes down here. 1 and 0 is 0, and the circuit stabilizes. Therefore, when R is 1, H is 0, and Q is 0, your output is going to be Q plus equals to 1 and P plus equals to 1. Q plus equals to 1, P plus equals to 1. As you can see, this is clearly a violation of Q not being the complement of P. So let's put a star here. See what happens when R is 1, H is 0, and Q is 1. So 1 goes down here. 1 and 0 is 0. 0 flip 1. 0 goes on top. This stays at 1 and the circuit stabilizes. Again, Q plus and P plus are 1 and 1. This is another violation. Now this is similar to the SR latch where the inputs S and R are not allowed to be 1. In this case, R cannot be equal to 1 and H cannot be equal to 0 because this is a race condition. The race condition occurs when R equals to 1 and H equals to 0, similar to the invalid state in the SR latch. Let's look at the last two combinations. R is 1, H is 1, and Q is 0. So R is 1, H is 1, Q is 0. 0 goes down. 0 and 1 is a 0. Flip. 0 goes on top. 1 or 0 is 1. This goes down. 1. 1 and 1 is a 1. 1 flip, 0. 1 goes on top. 1 or 1 is a 1 and the circuit stabilizes. Therefore, when R is 1 and H is 1, Q plus is 1 and P is 0. So Q plus is 1 and P is 0. This condition is satisfied. That's okay because Q is complement of P. Let's check the last combination. R is 1, H is 1, and Q is 1. So all these three are 1s. 1 goes here. 1 and 1 is 1. 1 flip 0. 1 goes stop. 1 or 1 is 1 and the circuit stabilizes. Clearly, when R is 1, H is 1, and Q is 1, your output remains at 1. So your Q plus is 1 and P plus is 0. This is similar to the set conditions in your set reset latch or your SR latch. So these two inputs are valid. Therefore, for this latch to work properly, the restriction on R and H is that R can never be equal to 1 and H cannot be equal to 0. So that's the restriction.